Bismillah ar-Rahman ar-Rahim, June 2024 and 43 variant question we are doing now, complete paper 4 now. So all of you get ready. 2 points P and Q, masses are given 0.2 and 0.5. Okay, so have a look here. All right. Okay, this is a P particle, this is a Q particle, there's a mass 0.2, there's a 0.5 mass. And situation is we have this. Okay, and after collision, what is going on? He said that P is thrown upward speed of right side to 6 speed. Okay, and this is, I think it is not moving. Q is not moving at rest, he mentioned clearly. Smooth, okay, and second is a P moves with a speed of 1. Naturally, we have 2 options here. Q will go 100% rightwards, okay, there's no doubt about it. But P will move right side 1. We have 2 possible values, we have to find it. One is, you know very well, when a lighter particle hit with a bigger particle, so maybe they will both move right side. Second option, if the so I'm discussing this one. So formula is m1u1 plus m2u2 equal to m1v1 plus m2v2. So let's apply. Mass 1 is 0.2, speed is 6. So 0.2 times 2, 6. And there's a 0, so because no motion, so I'm writing 0 only. So 0.2 into 1. So when I multiply 0.2 into 1 and this 0.5 into V, 0.5 into V. So this will go there. So, and when I check it, 0.2 into 6, this become 1.2 minus 0.2 equal to 0.5 V. And when I check in calculator, so this I'm getting 2 answers. So I'm getting here 2 answers. So first answer is very clear. I got here 2 meter per second. All right. So this is condition number 1 I discussed with you. But we have a second condition as well. What is second condition? Second condition is that if the lighter particle hit the heavy particle, so this will bounce back. Okay. When bounce back, speed will be negative. So I'm going to tell you why negative. Have a look carefully. So only this arrow will change, rest everything same. For your knowledge, because observer's eye is here. Okay, and we look at here, if this is coming here, what happening, you know, if particle is going away from observer, velocity positive, coming back to observer, velocity negative. But this is coming back to observer, so velocity negative. So what is the way? Again, the same formula I'm going to use. It is a very clear. So I'm finding, so this mass into this, so 6 times 0.2 into 6 plus 0, and here 0.2 into not 1, negative 1, and 0.5 times to V. So here I got a 1.2 and plus 0.2 and 0.5 V. So when I check it, 1.4 divided by 0.5. And my answer is turned to be 14 over 5, 14 over 5 meter per second. Okay, meter per second, or rewriting in decimal, it becomes 2.8. 2.8 meter per second. I hope so. The concept is very clear. And the question number 1 is over. Question number 2 we have, students. Question number 2. What a situation we have. If you look at carefully, mass of 0.2 is hanging, and naturally when particle hangs, the weight will act 100% downwards. There's a common sense of 2 newtons into 10. So another end, we have a fixed point with a vertical wall. You can see, and we have, this is the 90 degree. He mentioned perpendicular, and we have to make this a 30 degree here. And we'll find our tension and X. So let's learn how to find it. So first of all, I draw a perpendicular, or I make it a straight line here. You see here, I will make a straight line here and making a 90 degree. Obviously, this is a 90 degree. So this becomes 60 degree. And this is a straight line. Straight line is a 180. So when I from 180, if I subtract 60 and 90, 180 subtract 60 and 90. 60 and 90. So I got a 30 degree. So this is a 30 degree for sure. Now, students, because due to weight, the tension will go will be this way, this way. When weight hangs downward in a reaction, tension goes away. It has a two components acting. One acting is this way, and one acting this way. Okay, so this is a 30 degrees. So I will make this 30 degree here as well. This t cos 30 is all clear, and this is a t sine 30. I have resolved T force. Now let's talk about X with the 30 Newton for angle 4. Okay, so this is obviously this is because 30 mentioned here. So X cos 30. So we have a X cos 30 and we have here X sine 30. Okay, now because system is given in equilibrium, it mentioned clearly equilibrium. So what I can say, rightward force equal leftward force. So I am going to make it one connection. T sine 30 is equals to X cos 30. X cos 30. If this goes down, I can make it X is equals to this cos goes down, sine over cos tan 30 and tan 30. I can, or you can type as it is, even no issue at all. Or okay, this goes down, I got this one. So anyway, there's a one connection I got from here. So two forces acting upwards and one force acting downwards. I can make them also same one equation. So let's make an equation. T cos 30 plus x sine 30 is equal to 2. I have a two equations, students. I have to solve them simultaneously. I brought this cos down. I got a tan. This value of x, I'm going to plug in it here. So t cos 30 plus x value, I'm writing here t tan 30 into sine 30, already available, into capital T. This t actually I'm keeping it at the end. Okay. What is common from here? T common out. And in the bracket, I got a cos 30 plus tan 30 into sine 30 is equal to 2. When it goes down, I will get a t value from here. So I'm going to type in calculator. So 2 in the numerator, and down I have a cos 30 plus tan 30 and time to sine 30. And if I check it, I got attention become √3 exact value, which is actually, it is a 1.7321 newtons. But I don't want. So I got a 1.73 newtons. Exact value is √3. If I plug in this value here, I will get x. So x is equals to tan 30 times to √3. And for your knowledge, I just tell you tan 30 is √3 by 3. Or this become 3 by 3 become cancel, and I got x is equal to 1 newtons. So 1 Newton. Alhamdulillah Rabbil Alameen. This question is also clear. So a car travels, question number 3, we have a car travels a straight road, okay, constant acceleration. And the car passes point ABC in the same order. So it means, let's take a look here. I assume this A, capital A and capital B and capital C. Okay, speed of car of A is U. So what is speed of car here? U speed. And distance of AB is BC distance is twice than AB. It means if distance is D, this distance will be 2D. And car takes 8 seconds from A to B, so this time is 8 seconds. And 10 seconds for B to C. So this time is 10 seconds. And we have to get U in terms of A. So distance D and acceleration throughout is A. How I know? Because mentioned on the top, constant acceleration, not changing. So I have to eliminate D. How we can, so it means we have two formulas. 2AS is equals to V square minus U square. Second formula is S is equal to UT plus half GT, half AT square. So naturally, this upper formula I can't use. Logic, because in this motion, we don't have the V. Okay. So that is why the upper formula is not effective. The lower formula I will use twice. So first of all, from A to B. So S is equal to UT plus half AT square. S is D given, okay, and U is U, acceleration is A, or T is 8. I'm going to plug in all values. So I'm putting here D, and so U is U, and time is 8. Time is 8. So I got D equal to 8U plus 32A. How 32? 64 divided by 2. Okay, this is done. Now look at now, student. Can I apply same formula from B to C? No. One problem we are facing. Why? What problem facing? You don't have a U for this because here we have a U starting velocity. Do we have a starting velocity here? No, we don't have it. But we can use this data and get the final velocity of the first stage will become starting velocity of the second stage. So let's apply formula. V equal to U plus AT. And this I'm applying from A to B. U is U and the time is 8. You can see clearly. And U is U and acceleration is A and the time here. So V equals to U plus 80, 8A, sorry. This final velocity of this motion will become starting velocity of this motion. So U is, this will react as a U. So I'm applying formula again. S is equal to UT plus half AT square. In the place of S, I'm putting 2D. So 2D I'm putting here. U is this complete. I'm writing here U plus 8A times 2. Time is 10 seconds. So I'm writing 10 here. And A remains A. And here again 10. 10 square power 2 is 100. So I'm writing here 100. So this D value is coming in the place of it. So we can get rid of D. So this is a 8U plus 32A. And this 10U and plus 80A. And here I got a 50A. Now, student, very close because we have to make a U subject, but in terms of A. So 2 8s are 16, 64A, 10U, and 8 plus 51, 30A. Okay, so we have to make U subject. So this U goes there. Out of 10, 16, 10 gone. I got it 6U. And this goes on other side. Out of 130 minus 64. I'm getting double 6. And this 6 divides, I got 11A. So alhamdulillah rabbil alameen. I believe you got a point very clear. And let's go for the next part. Speed of the car at C in terms of A. Speed of car at C. We have the final speed we're looking for. This is not a hard job for us now because I can use this formula. V is equal to U plus AT. And I have a starting, what is the starting velocity at this level? Yes, we have it. I can use it. So in the place of U, I'm writing U plus 8A. Okay. And what is acceleration remain A? And what is the time is a 10. So we are close to finish U plus 18A. But so U value we have. U value is we have it. So velocity, and when we apply this formula, just calculate. So V becomes, so this is wait a minute. I have to plug in here 11A plus 18A. And if I check it, we got it now 29A. And he was asking to find final velocity in terms of A. Alhamdulillah Rabbil Alameen. The question is completely over. Question number 4 we have now, students. A particle travels a straight line. The velocity of particle from the O is given this formula. All right, the distance traveled for the first 2 seconds is 6 meters. It means I can say that, and he said that find the K value. So we have 2 ways to solve it. We can find C. Okay, look at here. We have 3 levels. First, we have a displacement, and we differentiate. I get a velocity. If we differentiate, I get acceleration. Okay, so differentiate and differentiate. If I integrate acceleration, I get velocity. Integrate, I get displacement. Currently, I am on the velocity level. I'm looking for, because he talked about distance traveled, so I have to come one level down. So integration. So V equal to KT squared negative 4T and plus 3. So I am integrating, but we have a two way of integrating. One way is with limits and one without limits. Both works. Okay. Without limits means I will find out a C value and then I'll plug in that one. So this both works. Second option, you plug in 0 2 because he said first 2 seconds. So 0 to 2 apply and get the answer without C value. But I think so I'm going for C. Students can understand easily. K, increase the power by 1, divide by same, increase the power by 1, divide by same, 3 becomes 3T. And I'm getting here C. And you know very well when particles start from O. So naturally when time was 0, distance was confirmed 0. If I plug in T0, S0, let's see what happens. So T0, 0, 0. So C becomes 0. I plug in back in equation, so I got a pure displacement expression, which I'm writing finally here. And now I'm going to plug in two things. What? Time is 2, distance is 6. So you saw times 2, distance is 6. So 6, 2 to the power 3, and 2 to the power 2, and here 2. So I got it here. I got, this is a 8K by 3, and 2, 4, 2 is a 8, and 6. So this is cancel out, and 8K by 3 is equal to 8, and 8 goes there, 3 divides, so we got a 3. So this is a K value 3. So one choice, if you don't like this way, you can take directly 0 to 2 limits, as you said, and 6 plug in the place of S and get the answer. This is a one choice. Second choice, I've showed you. In the first choice, we never get expression of displacement. But in this, with the plus C criteria, we always get expression of displacement, and then we can complete the next part. Anyway, next part is asking, find the minimum velocity. Let me tell you, if we go for minimum velocity or maximum velocity, how we do it. So we will differentiate velocity first of all, and then we'll plug in 0 and get time from here. And that time put in velocity equation. So this whole story. So let's go for, so let's first of all plan. So I have this expression available, but K is 3 now. I am putting it here, and same time I'm replacing K and writing 3 here. So first of all, according to criteria, as I said, this criteria is not for the maximum velocity. No. If you need a maximum displacement, I will differentiate displacement, put 0, get time from there, and put back in equation. If I'm looking for the maximum acceleration, I will differentiate acceleration equation, put 0, get time, and put back in a equation. This rule is fixed for every situation. So 6t minus 4, I will plug in 0. This is called derivative equals to 0. And I got time 4 over 6, or I can say 2 by 3 seconds. But time is not, I get time and plug in back in an equation. This is a compulsory, students. If we not put, we can't get the maximum or minimum velocity. We cannot get. I'm replacing this time value there. And if I type in calculator, students, I am getting here 5 by 3 meter per second, the minimum velocity. I hope so. The concept is very, very clear. Question number 5, we have now a van of the mass 4,500 kilogram is towing a trailer of mass 750 down the hill, angle theta. What is this one? Okay, all right. And the van and trailer are connected to a bar. Okay, and constant friction. This is on a van, and this much on trailer. Okay, intention is given by him, and we define acceleration and driving force. So let's try to do it. Bismillah ar-Rahman ar-Rahim. A big diagram is required for this because a lot of forces are there. So don't make a small diagram, students. So, so don't make a small diagram, especially in the middle. You'll need okay, this is done. So this is a connect. They are connected with a here. So first of all, let's talk about two forces acting here. One, applied force, which engine is working. Second, mass. Mass, how much? 4,500. And all of you know mg sine theta is a weight component. So when a particle is coming downwards, is a weight component mg sine theta. Okay, and this is theta. So mass is 4,500, g is a 10, and sine theta is 0.05. So I'm saving my time. I am just writing it here, 4500, one more zero for that one, and into sine theta. Okay, so this is very clear weight component, you can see easily. And before I start, do you know, students, whenever there is a tension acting to each other, that's for sure. This is a, they are pulling to each other. Both tension are equal to each other, same like that. If this string passes over pulley, so tension towards each other. And even this is kind of pulley, and this string's tension towards each other. Same story here, tension towards each other. I know some students confuse how it possible. So this is okay. That is why when this will pull this way, this tension will pull this particle downwards. Anyway, after this, friction acting on the van is 2,500. I'm writing here friction equal to 2,500 on V for van. So let's talk about this weight component of the other particle is, I'm writing here this one. So 7,510, one more zero into sine theta. And backward is a friction, which is a 300 Newton. You can see from here. I have shown almost all components. Yes, now. So let's talk about one by one. Because first of all, we go for acceleration and we have the, so I will talk about this particle. Okay, not van. Okay, so when I talk about this particle, because system is moving downwards, so common sense, these two forces are bigger, that is a smaller. I'm writing here, so for trailer, okay, I will say net force equals to MA. So how many force acting on trailer? If you check it carefully, tension, weight component, and friction. So I'm starting tension plus 7,500 into sine theta minus friction equal to MA. That is a 750 and A. And tension is given by him is 450. This time I'm replacing sine theta value, which is 0.05. And 750 acceleration. So I'm going to type in calculator full left hand side 7,500 and into 0.05 and minus 300 and divided by 750. And my answer is turned to be acceleration is coming 7/10 meter per second square. Or I can say 0.7. Okay, so this part is very clear. Now, student, let's first of all, I talk about this trailer. Now I'm going to talk about the van. Okay, so let's apply same criteria I'm going to apply on this one. As system is going downward, I will start from here. So again, now, so net force is equals to MA. So I'm writing here, students, 45,000 into sine theta. Sorry, plus I write capital F. And minus friction force and minus tension is equals to MA, which is 4,500 times 2 acceleration. And acceleration, I will plug in the value, capital F unknown. So 4,5 and 0,000. Let me check. Okay, yeah, into 0.05 because sine theta value. minus 2500, and tension, I know 450. So 4500 acceleration, I will type, acceleration, we have it. And I got it just now, 7/10. I will type this fully and bring on the other end. So first of all, I am typing in calculator 45000 into 0.05 minus 2500 and minus 450. And I'm getting here, this is becomes a negative 700. So 4500 into 7/10. I got a 3150. So 3150 plus 700. And if, so we got it, F is equals to driving force 3850 newtons. So Alhamdulillah Rabbil Alameen, part first is very, very clear. So let's go for next part. Another occasion, the van and trailer ascend straight hill incline. It means going down. Main point is they're going down. Okay. And wait a minute. Sorry, going up, ascend, not descend. Okay. So, all right. So same diagram will make it, but you know the diagram will reverse now. So better to make it a new diagram. Diagram is a very, very important. So as a teacher, I suggest you make it carefully. So okay. So V for van and T for trailer. So this is applied force. Okay. And now he talk about in hill. Okay. All right. Horizontal, this one. Okay. So this time sign is different. And driving force is given by him is let me write it separately here. That is a 9100. Okay, speed of the van at the bottom is 20. So V speed of the van is V van, okay, is 20. Okay. And friction remain unchanged, that you know very well. One friction is 2500, one 300. So friction on okay. What we need to find here? Acceleration in the van of tension tow bar. Okay. So with same story, we have tension definitely towards each other. Situation one, okay. And because the system is going upwards, we have two things here. There's a weight component, and that is obviously know it, 4500. Now put one extra zero into sine theta. And there's a friction force 2500. Okay. And because system is going upwards, make sure. Okay, that is why friction backwards. Okay. Now students, this has a two component acting downwards here. One is a weight component, which the mass is how much? 750. 750 and 4500. Yeah, 750. So 750. So 750. One more zero into sine theta. And friction is acting downwards is at 300 newtons. Friction. There's also friction. V and this T. Okay. I think I spend an extra time on diagram. That is very, very important. So let's try to do it. So as usual, and he said that now this time we have to find acceleration. So first of all, I'm starting from the previous question, students. You see, we have force was not given. So that is why I did not start from the van. I have started from the trailer. Okay. And that is why. But this part, which I'm going to do now, I'll start from the van. I hope so you got a point. So let's try to do it. So because system is going upward, so this force is bigger and this all components. So I will take these four forces, 1, 2, 3, and 4. So I'm saying capital F minus, okay, first I write formula and then mg sine theta minus friction minus tension equal to ma. Now I plug in the values. So I got a 9100. Mass is a 4, 5, and triple zeros. into 0.09. Friction is 2500. Tension, I don't know. Mass is 4500. Acceleration, we don't know. So I hope so you got it. I'm typing all values, left-hand side values. And 0.09 and minus 2500. And I'm getting from this all values, if I type in calculate carefully, I got a 2550 minus tension equal to 4500 times 2a. So this I got it. Second number, let's talk about the other one. So now we talk about these forces. So again, it's moving upward. So this is a bigger force. So I'm writing here tension minus weight component mg sine theta minus friction is equals to ma. Okay, tension is okay unknown. This I'm getting from here 750, one more zero into 0.09, and friction is 300. Mass is 750. Acceleration I don't know. So I'm going to type it 7500 into 0.09 and minus 300. And wait a minute, I have to type both carefully with a negative sign. So yeah, so I'm getting here tension negative 975 equal to 750A. Equation number 2. And students, I'm going to finalize it. Okay. Now, how to do it, this one, students? So I'm just solving simultaneously. So this equation I'm copying from here. And this equation I'm copying from here. Okay. Now, student, naturally, tension cancel. So 2550 minus 975. I got 1575. And 4500 plus 750. I got 5250 acceleration. So 1575 divided by this, I got a 0. Let me check finally. I got a 0.3. So acceleration becomes here 0.3 meter per second. Let me shift slightly up because needed some space. Okay, so this answer is finally, I got it 0.3. So Alhamdulillah Rabbil Alameen, this value I can plug in any one formula to get it. I'm putting it here. I'm putting it here. So T minus 975 equal to 750 times 2, 0.3. And tension, I'm getting it from here is if I check it, so 750 and 0.3 and plus 975. I'm getting here 1200. So Alhamdulillah Rabbil Alameen, we have done it. This, okay. So what is the last part of this question? Find speed of van when it's traveling distance of 375 meter up. So now we have to use this speed. This speed we did not use before. So speed was, starting speed is 20 and distance is traveling 375 meters. And speed of van he talk about. And acceleration remains same throughout. Okay. And now what is asking for? Find out speed of the van is travel. Okay. So 2as equal to v square minus u square. And acceleration is 0.3 and distance is 375. Last velocity target, u is 20 square. So 20 square add 2 into 0.3 into 375 plus 20 square. And take a root of the whole will give us the velocity. Okay, so I'm typing in calculator, students. 2 into 0.3 into 375 and plus 20 to power 2. And answer turned to be 25 meter per second. Just a lengthy question. I believe you can do it easily if you focus carefully on all components. This question is question number 6. We have a cyclist traveling along the straight horizontal road. The total mass of cyclist and her bicycle is 80. So mass is given here 80 kilograms. Okay. And constant friction force is what we have given 32 newtons. Okay. And assistant when it's traveling is speed is 7. Okay, speed is 7. Acceleration is 0.1. Okay. So just give an example. This is a particle or whatever, applied force, backward friction force. So what we use a formula, net force is equals to MA. I can say capital F minus small f is equals to MA. Power formula, all of you know, F into V. If I bring this down, so power by V is equals to capital F. I replace here P by this one, and I think so rest part is not a hard job. Plug in the values. V is 7, friction force is 32, mass 80, acceleration 1. So just if I solve it, here I got 8 and 32 adds, and I got a 47s are 28. So this is a 40. So P by 7 equal to 40, and power become 280 watt. I believe point is very clear. And Alhamdulillah Rabbil Alameen, we have done it. Okay, this is over. Okay, leave it here. So let's go for next part, students. Steady speed. What steady speed means, students? Steady speed means constant speed. So when a constant speed comes, so acceleration is confirmed 0. And he said, when the power output, find the steady speed. Okay, when can maintain his power output and resistance are unchanged. So again, same story. Capital F minus small f is equals to MA, and power by V minus friction force equal to 0. Power by V is equal to friction. Okay. Now, students, power is, he said that find steady speed. Power remains same. So 280 by unknown friction force is same, which is 32. So cross multiply. So 280 is equals to 32V. And if you divide it, okay. So if you divide it, so 280 divided by 32, we get it 8.75. So I hope so the point is very clear. Okay, this is done. So this part is over. Let's go for next part. So we have a part C. The cyclist later descends a straight hill of the length of 32.2 meters. Okay, and angle is given here, is very clear, descending, all right, and to the horizontal. Her output power is power is given. So let me read and write better. Okay, if we just read, we will not get easily. And friction and resistance to force motion with a such work done. So given here, work done by frictional force is given here 1128 joules. Okay, and time taken descent is a time how much? 4 seconds. All right, and we have to find out and distance. Straight hill, you know. Okay, let me show you. So distance is here, total is 32.2 meters, and speed at a speed at the top of hill. So what is speed here is 7.5, and speed at bottom we need to find. Okay, and what further thing we have given? Angle, we have it. We have angle. It's not a problem. And what a whole story. And let me check further. Okay, so students, what is a basic formula for the, we use always work done by applied force, work done by frictional force, kinetic energy plus potential energy at an end point. Okay, because he said that it is a descending, is coming downwards. So downwards means top, and B for bottom is coming downwards. So then speed is different. I have to take here U is and this will be okay. So U is speed as a hill. So that is U is 7.5. And we have to find last speed here. Okay. First I thought it's ascending, but it's now it's a descending. Okay. It's going down. So bottom minus top. So B for bottom and T for top. This is clear. So I think it's very clear. We are looking, this is given by him itself, no problem. Okay, we have to find this one. So how to find this one? Basically, work done, we can say, if we know the definition, work done. So we can say that power, um, and we have the power given here, and work done multiplied by time. Because basically, we have a formula, students, all of you know, what is the power formula? Work done divided by time. Work done divided by time. So if we multiply it there, I will get a work done. So work done becomes what, students? So work done by applied force, power time to time, power into time. Power is 120 is this one. So if I multiply 124, I got a 480. Okay, joules. So this I have it. It means this I have it. Now this I have it. What is the missing, students? I have some values. I need to find it. And let's try to find those. And first value which I'm looking for is kinetic energy at the top. So I'm writing here kinetic energy at the top. Half mv square. Mass, or how much mass is given not here. Maybe previous page that we have it 80. 80. Have 80 mv square. And that is a 7.5. Okay, potential energy on top, I want to find it. Potential energy on top is also mgh. M is 80, G is 10, H is I don't know. Because this height, I will find it. And basically, height is Howard's formula, H divided by 32.2 equal to sine theta. And sine theta, we have it. If I bring it, you see, if this theta is equal to sine inverse, 1 over 20. Sine goes there, inverse goes there. I got a sine theta equal to 1 over 20. So this value, I'm going to replace simple in the place of this one, 1 by 20. So it height, it tends to be 32 divided by 20. So 32 divided by 2 divided by 20. And height, I'm getting here 1.61. So which I can use here, mgh. I think all are understanding. So 40 times 2, 7.5 square, giving us 2250 joules. And 800 times to 1.61, 1.61. So I'm getting here 1288 joules. What left, students? Only thing is left, okay, kinetic energy at the top, at the bottom, sorry, at the bottom, B for bottom. And then, you know, formulas half mv square. I got a 40v square. Now, student, I will plug in all values. This value will come from here, 480 joules. And this value will come from here, and that is a 1128. Okay. And after that, kinetic energy at the bottom, that the formula, you know, is a 40v square. Potential energy at bottom because zero height, so 0. Kinetic energy on top, I have it. I have a 2250. Negative into positive, negative, and 1288. And now, students, I'm going to type this all in calculator, keeping 40 here, 40v square here, and 480, negative 1128, and positive 2250, and positive 1288. And I'm getting 2890. Divide by 40 and take a root of this, will give us 8.5. So I hope so. Point is very clear. So root of 289040. So velocity turns to be 8.5 meter per second. I hope so. The concept is very, very clear. Question number 7, we have, students. A diagram shows a track A, B, C, D. You can see the track A, B, C, and D. Okay, and vertical plane AB is an angle 30 degree. You can see it clearly, and smooth. So it means this smooth. So be careful. This is friction is not equal to 0 here. And section BC is a rough. BC is a rough. So here sorry, this is equal to 0. Friction is equal to 0. So this is called smooth. And F is not equal to 0, it means rough. And CD is an angle 30 degree and is rough as well. So this is also, it is not equal to 0. It means it has some value. So I hope so clear. Two, it means simple idea. This is smooth, so no friction, and other two parts we have a friction. Okay, and each length AB, BC is 2 meters. So it means very clear. I write S is equal to 2 meter, S is equal to 2 meter, S is equals to 2 meters. A particle released from rest A, so it means starting velocity at A is equals to 0. Coefficient of friction between B to C and C to D is through mu. It means here mu and here mu. Both are mu's, very clear. Okay. And the no change speed of particle when passes through B to C. It means what he's saying, when particle comes down, what speed here and what speed here? Same. And one particle reach here and what speed here? They are same. This he's talking about. So speed, no change. Normally in common, it is a real life is not possible, but he's saying you can assume like this. Okay. And what a question, mu is 0.1 for both rough surfaces, distance. Find distance a particle move up CD when speed is 1. It means first particle comes down, move this way, and it has a speed at this moment, velocity is 1. So we have to find out this distance. So this is a question. Find distance with particle moved up section CD and when speed is 1. So I hope so. The concept is very clear what he is demanding from us. So let's try to fulfill the demand. So first of all, we'll start A to B. So A to B. So A to B students, U is confirmed 0. Data writing is very important. S is equal to 2 meters. Okay. But problem is that, and what is my task? To find last velocity and acceleration. And students, you know, when a particle coming down the plane, and let's try to do it. So a particle is here, and what is this? Is always, you know it very well, mg sine theta. And backwards is a friction. Basically, formula net force equal to ma because system is going downwards. I can say mg sine theta minus friction is equals to ma. But you know, friction is not there because we know is a friction is 0. So as a friction is 0, so I will write 0 here. And afterwards, what happened? Mass and mass will. Okay, let me show. I just write it here 0. And mass cancel. This is a 10 and sine 30. Sine 30 is a half. And I got acceleration 5 meter per second. So it means that this is a very clear. So the particle is coming downwards with acceleration 5. Acceleration, I got it. Now I can find V. So we are 2as is equals to V square minus U square. 2 times 2, 5. S is 2 meters. Last velocity is target, U0. 2 to the 4, 5, 5, 10. Or 10, I got a 20, sorry, 20. And V square is equal to 20. And 5 for the 20. So I got a 2 root 5. Let me check 2 root 5. Yes. So 2 root 5 is a velocity. We got it just before reaching, just reaching. Okay, it means this is a very clear. It means traveling here speed is as a 2 root 5 here. Here speed and here speed same. And now it's moving on a horizontal track. Okay, but make sure now I'm going to talk about BC. So let's talk about B to C. Okay. Now, student, this common sense, this last velocity will become starting velocity of next stage. So this V, I am writing here U. And I want to find out last velocity with which it will reach here. But interesting, S is a 2 meter problem. Do you have acceleration? Answer is no. So, but now traveling is horizontal track. And horizontal track, what is the formula? Have a look carefully. But make sure this time capital F and friction force is there. Capital F minus friction force equal to MA. Applied force is not there. Why? Because it is coming due to its own weight is traveling. And there's no extra force is applicable there. And now we talk about friction. What is the friction? Mu R is equal to MA. And when a particle is there, is a capital R and there's mg. What is the mass? Mass is unknown. So this I can say 10m. So I'm writing here negative mu is 0.1, 0.1. You see, is given here 0.1. So I'm writing here 0.1 into 10m is equals to ma. Mass cancel, and I got -1 acceleration meter per second square during the horizontal track. I can find it now easily. 2as is equals to v square minus u square. Acceleration negative, s is a 2 meters, last velocity is task, u is 2 root 5. 2 root 5 is basically 20. Okay, so I do 20 here, -4 and plus 20 is equals to v to power 2. Because this goes there. Okay, and this is clear. And okay. And if I check it, this is becoming with 16, and root 16 is 4. So we got a second, this answer we use a previous one here and a 4. And this 4 will become u for the next stage. So this is u, this is, let's say it reaches here. And at this moment, last velocity is 1, according to the situation 1. And this s is my task. But interesting part, this speed and this speed same. So I'm writing now, what is data? B to C to D. So I'm writing here C to D. I'm writing here C to D. So I'm writing here C to D. Okay, students, so let's have a look. So this becomes U. This 4 becomes U. So U is 4 meter per second. And student, last velocity is 1 meter per second. And my task is to find it. The problem, do have acceleration? Answer is no. So now, student, first of all, I talk about inclined plane. This is an applied force. Though applied force is 0. And friction force and extra part mg sine theta. So because system is going this way. So I can see here, students, I think this is okay. Let me, because maybe I need some extra space to do it. Okay. So I can say here, students, so capital F minus 4f minus mg sine theta is equals to ma. This is a 0. This is a capital F is confirmed 0. Friction is mu r. And mu is 0.1. And r is what? Very interesting. R is what? This capital R, this is what? R, this is mg cos theta. So I'm writing in the place of here mg cos 30. Here I'm writing mg sine 30 and mass into x. Mass cancel out. In this way, I can find the acceleration. Let me check it. -0.1 into cos 30 and -10 times, wait a minute, I did just one mistake. Gravity. So -0.1 into 10, because G is 10, into cos 30 and -10 times to sine 30. And I got it here, acceleration -5.866 meter per second square. So this acceleration will help us to solve the answer, and let's try to solve. And what is the data? Data is mentioned here. I can use it. So 2as is equal to v square minus u square. 2 times 2 acceleration, which is a -5.8. And wait a minute. Okay, space a problem only. 866. Okay. I'm erasing it. Okay. I am writing it here because I need some space. And rest is not a, okay, this formula is very clear. I'm plugging the values. Okay. And S is unknown. V is 1. U is 4. So I'll find S from there. So 1 minus 16 over 2 times 2 -5.866. So when I find it, students, so -15 come in numerator, 2 times 2 -5.866, And we are getting here S is equals to 1.28 meters. So Alhamdulillah Rabbil Alameen. I hope so. The concept is clear for the part number 1. Yes, student part B, we have given instead of the different value of mu, it means what we find mu in the previous part is no more than same. Is a particle travel 1 meter up track C before it come to rest. So now it's stopped at a point after traveling 1 meter distance. Okay, and find the mu, and then we have to find out the speed of the particle in instant when it passes through C, the same point, second point, sorry. So let's see how we can do it, But first situation, you know it very well. If I take this data, this lines, so I think so we need this on next page. Okay, so C to D, E talk about, and this A to B. And here 30, here 30. So this diagram, I take it here, so you can understand easily. So what situation, student, we have this time mu is unknown, but this is a distance is equals to 1 meter. And last velocity here is 0. Okay. So what's the planning? This is here this remains same, and just before hitting the speed is 2 root of 5. Let me check. Yeah, 2 root of 5. Okay. So that remains same at this place. Okay. So now how we can do it? First of all, I will talk about C to D. C to D. Okay. So we have data given here. You can see V is 0, S is 1, and we have to find two things here. First, acceleration in terms of lambda, in terms of mu, and we have to find out initial speed. That is a very important, because what initial speed, that will help us to solve it from here. Actually, I'm going for reverse question like this. Okay, previous question I went like that. Okay, but this question I'm going to do like this. I believe you're understanding. So as it is going upwards, we need to find acceleration. So we have done it many times. I'm doing again. And why I'm doing again, so you can understand. Applied force 0 and friction force downwards and mg sine theta, you know it very well. Okay, now what is and R is this, and this is mg cos theta, whereas theta is 30 degree. Okay, capital F, because system is going upwards, so it means this going upwards. Capital F minus small f minus mg sine theta is equals to ma. F0, this is a mu r, mg sine theta is equals to ma. Mu r, mu is unknown, but r is equals to this. So I'm going to plug in the value mg cos theta, and cos 30 I can plug in now, minus mg sine 30, and is equals to mass into acceleration. Mass cancel out, and here I got the acceleration. If you check it, acceleration, there's a cos 30. Cos 30, if you check in calculator, is give us root 3 by 2. So this is a 10, g value is 10. If I multiply into 10, I got a 5 root 3. So negative 5 root 3 mu, it comes from here. And what is the other? This is simple 5y. Sine 30 is a half into 10 as a 5. So this acceleration, now I can find out the u in terms of mu. And what is the formula, students? So we can use it. S is equals to ut plus half 80 square. Okay. Or I think so if I use the other one is better. Other one is what? 2as is equal to v square minus u square. 2 times 2 acceleration, which is in terms of mu is here. And last velocity is, it stops on the peak. U is a task. And S is missing. S is what? S is 1 meter, as he said. 1 meter. Okay. So now, students, if I take a root of the whole thing, first of all, negative common out. So I get a u to power 2 is equals to 2 multiplied inside 10 root 3 mu and plus 10, because this negative came out and cancel with that. Okay, if I take a root even, so I will get this format. Okay, all right, this part is very clear. And what I believe that you're understanding the concept even. So now I'm going for the next part. And next part, obviously, I talk about B to C. B to C. When we talk about B to C, this starting velocity is, we have it already. So this is a 2 root of 5. And distance is 2 meters. We know this distance is 2 meters. Okay. Now we have a problem facing only, and what is my task? Last velocity I need to find with which velocity it reaches here. And for your knowledge, last velocity for this and starting velocity this are equals to each other. So this velocity I will put equals to this later on, and I will get my answer. This is a planning, because you know that last velocity B to C is equal to starting velocity from C to this part. So let's try to do it. But again, we are facing difficulty. We don't know why I'm doing this concept again and again. So you must understand the concept. So capital, okay, what is the net force equal to MA? And this is a, 0. This is a MA. And what is a mu R? And R, upward, down is a 10 M, okay? Because mg, so 10 M. So I'm writing here F is equal to mu R is equals to MA, negative mu R is a 10 M equal to 10 is equals to MA. Mass cancel. I got it here, negative 10 mu. So this is a negative 10 mu. I got a acceleration here. So students, what I will do it now, again, same 2as is equals to v squared minus u squared. And 2 times 2 negative 10 mu, s is 2 meters. Last velocity, I want to find it. And u is, 2 root 5. 2 root 5 square. And this is turns to be 2 to the 4 negative 40 mu. And this is actually 20. It comes this side plus 20. Because 4 5s are 20, I think you got my point, is equal to v2 power 2. So v2 power 2 and u2 power 2 are same. How come? Because last velocity at this level and starting velocity at this level. So these both velocities are equals to each other. So I can say here, so this v square and u square same. If you take a root, or no problem. So I will eliminate this. So I will put them equals to each other. So as I say that, as v square equal to u square. So I think idea is very clear. So 10 root of 3 mu plus 10 is equal to negative 40 mu plus 20. So this goes this side, and I got a 10 root 3 mu plus 40. And this equal to 10. Because it's subtract from there. And now I can take a, sorry, I missed the mu part. Yes, I missed the mu. So this mu. Mu is common. I got a 10 root 3 plus 40 equals to 10. And I get mu from here. So let me check in calculator. 10 divided by 10 root of 3 and plus 40. And I get the answer 0.1745 or 4. This is my mu friction value. I got it, new one. But question is not over. He said, find the mu value. I have done it. Now he's asking that particle go up, and stop on the peak. And he said, then it comes down and reach C once again, second time. So he's asking, find the speed of C second time. So now, it reach on top, now coming downwards. So naturally, it will travel same distance of 1 meter. It will start motion u0. Okay, and rest we see how we can do it. So let's try to do that part. So this is situation. So this is a C to D, but particle is traveling from here to here. And this velocity, I want to find it. This U is 0, S is 1. Again, we are finding difficulty is at acceleration. How to get acceleration? Because if I get acceleration, question will be finished. Okay, so let's talk about again. This is a weight component is mg sine theta and backward friction. So I can say mg sine theta minus friction equals to ma. Mg sine theta, sine 30, and friction is mu r equals to ma. And r I done 2-3 times previous part, mg cos theta. Okay, so mg sine theta minus mu is, I have it, 0.174. 0.174. And R is mg cos 30 is equal to m times 2a. Mass cancel. And now I'm typing in calculator. So let's see what happens. So sine 30 into 10, it gives minus 0.174 into 10 into cos 30, and I'm getting acceleration is 3.493 meter per second square. I think, student, we can get it easily to AS is equal to V square minus U square. So let's see how we can complete. Okay, so 2A is 3.493. S is 1 meter. Last velocity is target U0. Take a root of the whole thing. 2 into 3.493. So into 2, and I take a root of this. And my answer turns to be 2.64 meter per second. And I believe the point is very, very clear.